Happy Tuesday, 7th Excel. We only have 5 classes left here. So we are going to spend this week talking about systems of equations, and we're going to talk about it graphically. So we're going to get into part 1 today. We're going to do part 2 on Thursday. So what is exactly a system of equations? A systems of linear equations, so linear is just a fancy word for line, is two or more linear equations that use the same variable. Okay. What is the solution? What is the answer to a system of equations that you get? A solution or an answer to the systems of linear equations is the ordered pairs. Notice I'm saying that plural because there may be more than one. That makes all of the equations in the system true. So basically, guys, what we're going to be doing is we're going to be graphing two or more linear equations. For 7th Excel, we're going to just stick to 2 equations on the same graph, and we're going to find the ordered pair or pairs that make the system true. So first example, let's look at this. Use the graph at the right to graph the following equations. So I'm given 2 equations and they are nicely put into the slope-intercept form where it's y equals mx plus b. Okay, so I need to identify what my slope and what my y-intercept for each of these equations are. So remember, y equals mx plus b. Sometimes you will not get these in this form. And that's what we practiced last week, was getting these equations in this form if it is not given in this form. So my slope here, the steepness of my line is 1/2. So it's going to be rising 1, running 2. Rise over run. My y-intercept is positive 3. Okay, so I'm going to begin on my y-axis at positive 3, rise 1, run 2. Up 1, over 2. Up 1, over 2. Up 1, over 2. So the importance of me telling you last week, while I'm talking, I'm just going to keep extending my line here, of extending and drawing as many points as possible is not only because it creates a better visual for you to see where this line goes, but especially when we get into systems here, here's a couple key points. You want to be able to see these points because when we find the ordered pair in which that these solutions make it true, you're going to want to quickly be able to identify them. So that's why I've been really harping on you guys to draw points. The arrows indicate that this line will continue on in each direction. And this is why I make you label, because now when we get into systems, you need to identify which line goes with which equation. So this one is the y equals, and you can label wherever, but make sure it's close to your line here. Y equals 1/2 x plus 3. Now let's graph this second linear equation. Y equals 2x. So my slope is 2. Rise over run. If I had to write this as a fraction, it's 2 over 1. My y-intercept, or my b, I do not have one. It is 0. Okay, it's going to pass through the origin. So I'm going to begin at my origin on the y-axis, and I'm going to rise. This is positive, so it should be an uphill line. Okay, I'm still seeing a few of you guys make mistakes. You have a positive slope here, but you're drawing a downhill line. Okay, those got to correlate. Those got to match. That's a good indication whether you have it correct or not. So my rise is up 2 over 1. Up 2 over 1. Up, I'm hitting this point. That's going to be an ordered pair that makes this system true. Up 2 over 1. Up 2 over 1. I'm going to go back down. Okay, I'm going to use my straight edge. Putting arrows after the points. Okay, they're not on a point. Arrows don't go on a point. And I'm going to label this line. I'm going to come down here so I have it labeled and it's not too close to that one, it doesn't matter as long as I can see which line goes with which equation. If you do not label, I do not know which one is which, especially if you make a small mistake somewhere. Okay, you will lose credit on the entire problem. Okay, and that's the case on when you take your algebra regents next year as well. So I have my 2 lines graphed, I have them labeled. Now, the solution to the systems of linear equations. So do the graphed equations have any points in common? So grabbing a highlighter here. Right here, this is the point that they have in common. Okay, so remember, points are written, or an ordered pair is written x then y. So remember, this is your x-axis, this is your y-axis. A few of us are making some mistakes on this, writing an ordered pair. My x value to this point is 2. My y-axis value is 4. So the point that they have in common is over 2, up 4. Okay, so that is considered the ordered pair, or the point that makes the system true. What do I mean by that? And this is where I'm going to show you in the check. I'm not going to require you to check everything, but I want you to understand why this is a solution, or why this makes it true. Because what happens, guys, is if I plug in the point 2, 4 to both of these equations, it makes it true. So I'm going to write this equation and the second equation. So I'm going to plug in 2 for my x value and 4 for my y value. 4 for my y value, 2 for my x value. So here, this is a quick and easy one. 2 times 2 is 4. 4 equals 4. That means that this point satisfies this line. What that means is it is on the line. Okay? And a half times 2, well, what's a half of 2? 1 plus 3 is 4. 4 equals 4. So this proves, this is how you check, these both work out. Therefore, we know this point satisfies both of these equations. Okay? So using the problem above, describe in your own words how graphing equations can help you find the solution to the systems of equations. So we're doing it graphically. It's nice that we're doing it graphically because we can visually see the point in which they cross. Later in algebra, you're going to learn how to do it algebraically, not graphically, by solving for these. Okay, we're not going to get into that today, but I just wanted to explain, and I want you to be able to describe how graphing equations can help you find that solution. It's the point in which they cross that makes both equations true. So let's try a couple on the back side here before I let you guys go loose and do some on your own. We're going to graph both of these. So notice these first two, or example number 3 and 4 here, are written in our nice y equals mx plus b form, okay? And you're going to notice here, this one's written in y equals mx plus b form, but this one is not. So we're going to have to do a little work to get that one, which you guys do know how to do that. So let's go ahead, let's graph this here. My m is -1/2. My b is 3. I know this takes an extra about 2 or 3 seconds to do, but some of you are still making mistakes. This might be a strategy to help you keep on track until you really got it down pat. Some of you are doing absolutely fine and can identify them pretty quickly. This right now here, we should identify this does not have a y and an x. Therefore, this is a straight line. This is a straight line passing through the y-axis. All right, so let's graph this guy. My y-intercept is 3. And my slope is negative. It should be downhill. So I'm going to go down 1 over 2. Down 1 over 2. And I'm just going to continue my pattern until I run out of space here. Okay, couple things, making sure you're having coordinate points, nice straight line, arrows on the end after the points, and I need to label this because now I have multiple equations going on the same graph. This is a very important concept, okay? This next one, okay, I do not have a slope. My y, it's going to pass through the y-axis. Remember your y-axis, y to the sky. It's going up and down. So on the y-axis at 5. So here's on my y-axis. There is 5. It is going to pass straight through. Okay, this one is y equals 5. All right, can you identify a point in which satisfy or make these systems true? Hopefully you see right here is where these two lines meet or cross, okay? What the solution to that is the ordered pair of this point, which, remember, x then y, so that's -4, comma, my y-axis is 5. This is called the solution. Okay, if you wanted to check it, you could plug these values into your equation and make sure they are equal to one another. So watch this one real quick. My y value right here, x then y, is 5. Is 5 equal to 5? Then you did that part right. When you plug in my x value here, -1/2 times -4. A negative times a negative is a positive. Half of 4 is 2. 2 plus 3 equals 5, which that is what my y value is. So it will not require you to check on each of these, but I just want you to keep in mind that these should make sense in that capacity. Let's take a look at number 4. I want you to identify what is my m, what is my b for each of these equations. My m for the first equation, my slope is 1/3. My y-intercept is -2. For the second equation, my slope is -1. My y-intercept is 2. So now let's graph both of these equations. Okay, I went ahead and graphed these. Starts at -2 on the y-axis, up 1/3. Positive slope, positive uphill line. The second graph starts at 2 on the y-axis, negative slope. I have a downhill line going down 1/1. Okay, so the solution to this system is where your two linear equations cross. Okay, that point is your solution. So if you take a peek, we write our points, x then y. So my x-axis is 3. My y-axis is -1. So at the point 3, -1, that is your solution to this equation. There is one solution because they only cross at one point. All right, number 5. Okay, I can easily identify my slope and my y-intercept for this one because it is written in slope-intercept form. Y equals mx plus b. So my slope here and my y-intercept here are what? Okay, you should have a slope of -2. +6 is the y-intercept. So let's graph this real quick. Okay, there's my graph, +6 y-intercept. It's a negative slope, so I have a negative downhill line that correlates. I labeled my line. Okay, so now let's take a look at this guy. We need to work to get him into y-intercept form. So we want our y alone out in front. So we want to get my y value up here alone. So what do I want to get rid of first? I'm first going to get rid of my -6x by adding 6x to both sides of the equal sign. That allows me to move it to the other side. And I'm going to move this up to the top so I have some space here. This is a little cramped. 2y is left on the left side equals, remember you want your x value in front, 6x, your constant in the back, which is -8. Okay, remember you cannot combine those, not like terms. Last step to getting y alone is to get rid of your coefficient of 2. So I'm going to divide all terms by that 2. And I'm left with y equals 6 divided by 2 is 3x. Some of us are forgetting this variable. You cannot. It completely changes your equation if you take out an x. And negative 8 divided by 2 is negative 4. Now you've done your job of getting your equation in slope-intercept form, and it's very nice and easy to be able to graph this. So my slope is what? My y-intercept is what? Okay, my slope is 3, my y-intercept is 4, so I'm going to begin on my y-axis at negative 4, up 3 over 1, up, I can see right there it crossed, but I'm still going to make the best line possible. Draw a nice straight line. Do not forget to label it. Okay, key thing here is I always label with my original equation, because if for some reason you make a mistake on converting this equation into the slope-intercept form here, if you label it with this, I can still give you some credit because you thought that this was this, in case you made a mistake. So I always say label it with the original given equation, and it's better safe than sorry. So does anybody see a point in which these linear equations cross? This point right here is your solution. We're going to write the coordinates of this solution. On the x-axis, it's 2. Y-axis, it is 2. So my solution is 2, 2. Okay, that is the point in which satisfies both of the equations. All right, one more here. I'm going to have you guys tell me what is the m and what is the b for this equation, because it is already written in slope-intercept form. And I want you to do some work, and I want you to get this into slope-intercept form and tell me what that would be. Okay, so the slope on this equation is 1/2. The y-intercept is negative 2. On this equation, I first added my x to get the inverse, moved it over here. That left me with 4y equals x minus 4. Divide all terms by 4. There's a 1 up here that's invisible because that's 1x, so that's a 1/4 x minus 1. So my slope here is what? My y-intercept is what? Okay, I just graphed both of these right on the line, or right on the graph here. So, and I labeled both of them. So this one is my 1/2 x minus 2. And this one is this original negative x plus 4y equals negative 4. Okay, so those ones are close together, but where do they intersect? This point right here is their intersection point. Notice that's right on the x-axis, okay? So, x-axis at 4x, y-axis is right at 0. It did not go up or down any. So your solution to this systems is 4, 0. All right, last one here. Parking garage A charges $3 per hour for parking. So how would we write that, guys? Y equals $3 per hour. So Y is your total cost. X is what it is per hour. Parking garage B charges a fee of $2. That's that one-time fee plus $2 per hour. Remember, that's your unit rate, $2 per hour. Because you could find the rate for 5 hours, 10 hours, 6 hours, okay, by multiplying by 2. So $2 per hour. So Y equals $2 per hour plus that one-time fee of $2. Okay, so there's your two equations. I'm going to graph these both, and let's take a look at their solution. Okay, so there's my slope and my y-intercept for that first equation. and my slope and my y-intercept for the second equation, okay? This is my first equation, y equals 3x. I labeled it right here. Here's my second equation. I labeled that right here. So the crossing point here, as you can see, look carefully. These points do not cross, but these two are right on top of one another. That is your intersection point. So what is the solution to the systems of equations based on this graph? X and y is a point, so 2, 6. Okay, what does that mean in this context? Remember, this is X and Y, so be careful here. What does my X mean? This is $3 per hour. This is $2 per hour. So what do you think X means? This means 2. Sorry, my screen froze, guys. What this means is X is $2 per hour, okay, where they both meet. So for both garages, 2 hours of parking cost, remember Y is your total cost, $6. So for both garage A and B, so for both garages, 2 hours of parking cost $6. Okay, remember this is your total, or this is your per hour. In this case, this equation was $3 per hour. This was $2 per hour plus a $2 fee. Y is your total cost. So for both garages, 2 hours of parking cost $6. And that is the only point at which these garages would cost the same. So you can kind of look at 1 hour, you can see which garage would cost more. Okay, this garage right here, this is the second equation. So garage B would cost more, but at 2 hours, they'd cost the same. And then as you can see, after that, garage A would become a little bit more costly. Okay. All right, so that is your lesson for systems of equations today. You guys are going to do a practice activity on this, and I will see you Thursday. Have a great day.